Hello, I'm Annie Graham Larkin, Executive Director of the Bisbee Mining and Historical Museum. Welcome to The Forgotten Caves of Bisbee, Arizona, with Douglas L. Graeme and Richard W. Graeme IV. Thank you to our members and donors who enable the museum to provide free online programming and fulfill the organization's mission to discover history, explore Bisbee's past today. To learn how you can assist the museum in supporting its mission and programs, by becoming a member or donor, please visit bisbeemuseum.org. On Saturday, September 20th at 11 a.m., the museum will host the free online program Buffalo Soldiers in Cochise County with Dr. John P. Langelier. To register or for more information, please visit the Bisbee Mining and Historical Museum's Facebook page. Okay. Douglas L. Graeme, born in Bisbee, Arizona, began collecting minerals and artifacts underground at just the age of 6 years old. His lifelong passion for Bisbee's mineralogy took root early, and by the age of 13, he and his twin brother Richard were presenting their discoveries at the New Mexico Mineral Symposium. After studying mining in college, Doug worked across the U.S. from Alaska's gold dredges to underground mines in Colorado and New Mexico. He later served as a guide at the Queen Mine in Bisbee and contributed to the development of Kartchner Caverns. Today, he manages the Queen Mine tours and continues to share his deep knowledge and passion for the region's rich mining legacy. And Richard W. Graeme IV has worked in mines in Alaska, Colorado, California, and New Mexico. He also worked in Bisbee at the Queen Mine tours as a guide, where his knowledge base was put to full use. Because of the difficult times for the domestic mining industry, Rich switched from a mining major to education. He earned a degree in education from the University of Arizona in 1999. He has been teaching for 26 years in southeastern Arizona. During this time, Richard has authored and co-authored several books and articles, including The Mineralogy of Bisbee, Arizona, Volumes 1 and 2, 7 Bells, Mine Accidents at Bisbee, Arizona, and Forgotten Caves of Bisbee, Arizona. And if you would like to ask any questions during the program today, please type your questions in the Q&A chat box, and we'll share those questions with our speakers after the presentation. Also, a link to the recording of today's program will be sent to all of our Zoom registrants later today. And with that, I'd like to welcome Richard and Doug. Thank you for joining us.
Good morning, Annie. Good morning. I'm Richard Graeme, and this is my brother Douglas, and we are going to be discussing the Forgotten Caves of Bisbee. From the original mining beginning in 1880 until 1926, a large number of natural caves were intercepted in the underground mine workings, and we're going to talk about these. Just for those of you who are not local, we're located down in Bisbee near the Mexican border, and the largest cave that's in the local area is Kartchner Caverns, so approximately 40 miles away. Now, in between here and there are a large number of smaller caves that are just dotted, but these are geologically not really related to those that formed in Bisbee. Now, if we look at Bisbee, this is Bisbee in the late 1890s. You can see the large open cut on the hillside. That is the original Copper Queen mine. It shows the what is known as the Copper Queen open cut. And then the little building a little bit to the left in the bottom is an incline shaft, and that's the original Copper Queen incline shaft. And it paralleled the that open cut extended underground, and there was an incline shaft that paralleled it at 45 degrees until it went 200 feet vertically below the surface. And then, and we're going to talk about that open cut in a second. But we need to understand that the mines of Bisbee were a substantial underground mine with over 2,200 miles of underground workings. And although by modern standards, the copper production is fairly small, just 7.9 billion pounds, the gold, silver, lead, zinc, and manganese are still very respectable production figures. So it was almost immediate that they were uncovering caves in Bisbee, and this first began in that open cut that we looked at on the photograph of the hillside. And so there were questions on why they were here, how do they relate to the ore. Now, this is a photograph of the Copper Queen open cut in about 1883. Now, the lower 2/3 of this today have been filled in by material coming from when they put in Highway 80. Now, in the upper right corner, you can see a little opening and there's a little cross timber, a little stall going across. If you go in there, and it's still accessible today, the mine tour uses it as part of their ventilation path. There's a natural cave in there. And as if you were to continue down in there, you would find 2 or 3 other natural caves. Now, these were being exposed before 1883. And so immediately they started to suspect that the ore was directly related to the caves. Now, later that would be proved wrong, but at this early stage, they weren't quite sure. And they had reason to believe. This is samples of that ore. It's sort of a light green malachite, filled with a lot of calcite. It is often in the bottoms and in the sides of these natural caves that they were finding at the beginning. So they were thinking that it is what is now called paleokarst. They were suspecting that the caves had formed and then the copper bearing solutions had come in and deposited the malachite and the azurite that was being found. Now, at this time, the big sulfide ore bodies that would be uncovered later had not been discovered. So they had only found significant amounts of what is referred to the carbonate ores, which are azurite, malachite. Some of the oxide ores like cuprite and native copper had been found, but none of the real big sulfide ore bodies. And if you look right here, you can see in the, okay, there I go, found my pointer. You can see this cave in a limestone is directly above an ore body right here. And this is just in a section. And those of you who are somewhat familiar with Bisbee are probably going to get a little confused by the Goddard. The Goddard mine is actually the Holbrook mine. It was renamed that very quickly, and this tells you the date of the map is significantly older than most mine maps in Bisbee. And so they were seeing these caves with ore in the bottom, but sometimes they were finding caves that didn't have ore underneath, but they always had these iron oxides directly underneath them and in the bottom of the cave. And sometimes they were finding small ore bodies that didn't have caves at all. So they were developing this idea, or working with the idea that the caves, of the relationship between the caves and the ore. Here's a photograph of 2 of the caves found in the 1890s. It's a significant size. You can see a ladder right down in here, so they're pretty substantial caves. Neither of these are believed to exist any longer. They were destroyed by further mining. Now, mines and caves are commonly associated with each other. There's a large number of mining areas that have natural caves that have been uncovered in the mines. You know, sometimes they're like at Hanover, New Mexico, they were finding smithsonite inside the caves. The Mississippi Valley, the tri-state lead zinc mines are sort of classic in this way because it's a paleokarst. Is where the caves had formed, and then later on, in the case of the tri-state, these lead sulfide minerals were deposited inside lead and zinc. Sphalerite and galena were deposited inside these caves. And then, you know, over at Gleason, you have Defiance Mine, which had wolfenite lined caves, and then the Glove Mine out in Santa Cruz County had a similar situation. So caves and mines are not uncommon. Now, we're going to take a look at the speleogenesis of the caves in Bisbee. This is how they're formed. Okay, this became very important for the mining companies because of the association of the caves with the ore. Now, the view that we have in front of us is of Bisbee. You can see the town up on the left or up on the right. To the left of the town, we have these large limestone mountains. And in the center, we have the Lavender Pit copper mine, which is a fairly good sized open pit mine. Now, it all starts, let's do a quick geology and a very simple one. It starts 200 million years ago. At this time, where Bisbee's at, we had just these flat beds of limestone, of Paleozoic limestones. Soon after this, there's an intrusion, a volcanic intrusion, and it comes up into the limestones and it starts to break them apart and shatter them. Where the intrusion is where the open pit mine is and the orange colored hills that are surrounding it. Right in that area. Now, up along this volcanic intrusion, we had pulses of hydrothermal solutions come up along it. We've had at least 4 of them. And these solutions, they're high temperature, they're bringing up with them the metals like copper, iron, tellurium, gold, silver, lead, zinc, but also with them sulfur. Okay. Now, when those solutions enter the limestone, they're going to start to replace it, and they form these irregular shaped masses. Now, some of these can get in excess of 1 million tons. And they're replacing the limestone with your primary sulfides. The most common replacement is pyrite. You're also going to get chalcopyrite and boronite. These are the copper-bearing ones. Now, these replacements are pretty faithful, okay? And when you start looking at the sulfides, you can distinctively see fossils that were in the limestone that got replaced, things like crinoid stems and brachiopods. Geological features will also be preserved, like faults that have been preserved in the sulfides. One spot in the junction, which is absolutely incredible, is you'll see a chert bed that starts in the limestone. It's carried through the sulfide deposit and exits back into the limestone. And this slide here actually shows bedding planes that have been replaced by pyrite in this case. Now we're getting large quantities of pyrites, and below here you can see guys drilling into a wall of chalcopyrite, boronite, and pyrite mixed together. Now, time's going to go on. Bisbee is subjected to some mountain building events, the Laramide orogeny, basin and range block faulting. And what occurs in this is the land in Bisbee is tilted to 30 degrees, dipping to the east. Okay. In this image, the important thing to notice are these kind of black blobs. These are ore bodies. Okay. And you notice that the western side, the ore bodies are now brought close to the surface. For those people that are from around here, you can, when you head towards Douglas, you can see the mural limestone. You can really distinctively see the dipping beds there. Now, this is a top-down view of it. The brown is ore bodies that have been mined out. The ones on the right side are the deeply buried ones to the east. On the left side, you'll see the gray area. This is where the oxidation caves are distributed. And this is the section that has been brought close to the surface due to the tilt. Now, with the tilting, this causes surface erosion, which brings the ore close to the surface, and the meteoric waters, the rainwater, etc., are coming down through the limestones, and they start oxidizing the primary ore. Okay, when this occurs, the the water is going to create a lot of sulfuric acid from the sulfur in there. It also is going to create ferric sulfate, which is very reactive and was going to further what's going on here. Now, there's going to be excess acid, and it makes its way down below the ore, and it starts filtering along the bedding planes and the fractures, and it's dissolving part of the limestone away. And what gets deposited down in here is a siderite boxwork. Siderite is the iron carbonate. They're also going to generate quite a bit of carbon dioxide gas. Right. Now, the ore body itself is changing. It's starting to lose its sulfur, and the minerals you're going to find in it are your secondary copper sulfides like covellite and chalcocite. Malachite and azurite, the copper carbonates are going to start to form. The carbonates coming from the dissolved limestone. You're going to start getting a lot of iron oxides and copper oxides. Because you're losing some of the sulfur, you're going to start seeing rooms appear above the ore. And here we have a slight small one up above. Now, the image to the right is showing a pillar of pyrite that's starting to oxidize. The orangish reddish color is actually goethite that's forming there, the iron oxide. Now, this is a photograph of siderite boxwork. It's about 3 feet across the image, and you can see how it has a lot of voids in it. And this captured a lot of the carbon dioxide gas. In fact, there was one time when they were mining, they intercepted some of the siderite boxwork here, and actually had to evacuate that section of the mine due to the carbon dioxide gas that was released. Now, these are two images of a cave that's been partially oxidized, or ore body that's been partially oxidized. There is a small cave. You can see in the top photo, there's some popcorn calcite on top. The cave is fairly low lying. To the left, the cave has actually been backfilled. Okay, it's full of waste rock, and you can see rotten timber. There's actually explosives on that one too. To the right side, the room opens up. Now, and then it's mostly filled in full of goethite and hematite. When this was forming, it was a low pH environment, extremely caustic, and it was pooling up, and you were getting kind of these scums on the top, and they're forming what we call rafts. And as they got heavy, the rafts would sink down to the bottom of these acidic pools. And the photo to the bottom is just showing these rafts stacked up. In a second, I'll show you a close-up of one of the rafts. Now, these environments still exist today and are still ongoing. To the right, you see a crosscut that is filled full of iron hydroxide stalactites. These are, and below you see stalagmites that are forming. These are below a big pyrite ore body, a sulfide ore body that's starting to oxidize. Yeah, in fact, this is such low pH environment, some of the timber will actually carbonize from getting attacked from the timber or from the acid. And you can see to the left is a photograph of goethite stalactites, which are iron oxide stalactites that exist in the cave that was just on the last image. And they're very similar to the ones that are growing inside the tunnel there. These have been coated in calcite. And bottom left, iridescent goethite is just showing the raft litter. This is this little rafts that form on top of that acid solution. Now, full oxidation. Okay, over time, you'll have enough water come in, it will fully oxidize the ore. The sulfur has been removed and been carried elsewhere. The sulfur in the ore body was about 1/3 of the volume. And what develops is these little rooms above the ore bodies. And these are what turn into natural caves. The siderite boxwork, due to the acidity of the solution and the kind of collapse, will go away. The ore body underneath the ore body that remains is converted to copper carbonates, copper oxides, native copper, and iron oxides. Now, because these rooms are unsupported, they're going to start to collapse. Okay. And in the middle of these rooms, you'll see these huge breakdown piles. Okay. Now, one thing about the caves in Bisbee, stalagmites are not as common. Okay. And this is because the floors of the caves are in motion. Okay. And it helps prevent them from forming. Now, other collapse structures that are going to start to appear are the beds are going to start to dilate. Okay, they're going to start to separate a bit. And above the caves, often you'll get what we call a sag cave. Okay, now these things are generally not very large, maybe 3 to 6 feet tall, but highly decorated with speleothems or the cave formations. Another feature that you're going to get are marginal cracks. These are cracks that are on the boundaries of the ore body, and they often go all the way to the surface on that. Now, the photographs to the right are showing breakdown piles or fragments of them. The top photo shows rosacite, which is the copper zinc carbonate. The boulders are about 2 meters or 6 feet across in there, and below is just broken boulders of kind of a spongy malachite. These boulders are probably 16, 18 inches across on this. Now, these images are going to show some of the geological features that are caused by the caves. Now, the photo on the top right is a tunnel that's going through limestone that borders the cave. And you can see that the blocky limestone and the beds are starting to dilate. Okay, separate there. This would have been a nightmare to mine through because these boulders would have tried constantly kept falling out. The photo to the left of that one shows a domain crack. Okay, that's part of the beds dilating. Below, you'll see a marginal crack on the surface that is filled full of taprotene calcite, kind of get you an idea how old it was. And to the right, you're going to see a marginal crack inside the copper queen mine. Now, what it looks below the cave. Okay. To the right, the photograph shows a massive, it was pretty much just pure pyrite, very little metals were in this area. That's why it still exists. You can see all the red hematite, the yellow goethite, and they're clay-like. Okay. There's some dark brown things kind of in the center, like right here and right there. These are actually limestone boulders that kind of collapsed and got caught up in this stuff. And you'll notice that it's brecciated inside the iron oxides around. Now to the left is an ore body that it still has copper in it. Okay, you can see the green malachite. These are actually coating cuprite nodules, which is the copper oxide. Again, lots of clays that are iron rich are being shown here. Now, the caves in Bisbee are limited to 3 rock units: the Naco limestone, Escabrosa, and the Martin limestone. We do find ore bodies in the Abrigo. The problem with the Abrigo is it's very shaly and it cannot support any large rooms at all. So the caves that are forming in these things, they just entirely collapse.
Okay, and we're gonna take a look at some of the caves in specifically, and let's go on to the arguably, well, the most important cave. Oh, I forgot. We're gonna go into minerals that we find in the caves. Okay, so we have in this cave right here, we have malachite showing up. And in this area right here, there's a little bit of azurite down in here. It's very typical for the caves in Bisbee to be tinted with the copper salts. Typically, if it is calcite, the stalactite or cave formation is made out of calcite, it's going to have a greenish tint. The less common aragonite cave formations
tend to go a very distinctive blue color. In this case right here, the bluish color is actually not aragonite, it's presence of rosacite, the zinc copper carbonate staining those. And then up here we have a view of some calcite, again tinted by the copper salts, very typical of what was found in the caves in Bisbee. Very common, very, very typical. Less common were stalactites of azurite and malachite. The largest malachite stalactites, and this is the green one on the right, extended probably about around 3 feet, is the largest one that I've seen. And I will recognize that this one used to be azurite and has altered to malachite. But malachite stalactites are the most common of the copper carbonate stalactites. They were fairly abundant. The cave that this one came out of, there is no record of. Yet there's a significant number of pieces in museums that have come from that. This piece right here was originally in the American Museum. The Arizona Sonora Desert Museum has a really large one in their collection. Unlike malachite, azurite typically doesn't like to form a stalactite. And one thing that we have noticed in Bisbee, all azurite stalactites have an iron oxide core. So a little thin stalactite of iron oxide formed, and then later on it was coated with azurite. Typically, you don't see azurite stalactites longer than about 12 inches. The most important cave in Bisbee, I'm going to go ahead and say that, was the cave that was hit in 1895. And there are no photographs of it, but there are thousands upon thousands of pieces that were removed from it. It's hard to imagine a major collection that deals in minerals worldwide that does not have a piece from this cave. There's some in the British Museum, the American Museum, the Smithsonian, the French museums have pieces from this. Just about every museum you can imagine has a piece of this. And this cave occurred on the 200 level of the Czar mine in the new southwest ore body. And it wasn't really the main cave directly right over the ore body, but it was in a marginal crack to the side. And it was about 60 feet long, and it was curved, and it was about 20 feet tall and about 15 feet high, or 20 or 15 feet wide. And originally, the cave was sort of a rather unattractive place to be, because it would have been all iron oxides, it would have been reds and browns, very opaque, very dirt-like in some areas. But then, after the iron oxides formed, the cave became flooded, completely flooded with copper-bearing solutions, and then you started to get azurite crystal growth, and it was dominantly azurite. There is some malachite, but the far majority of it was azurite. And you had these periods of time where the cave was relatively dry, probably not completely, and then you had another period that would be completely flooded. There was at least 4, most likely 5 periods that have left their mark. There could have been others, but they just haven't left a distinctive mark on the specimens that exist to examine this. Now, what's interesting is you saw the little green dots all over the previous piece, and this is very typical of the material. They look, well, what they are is, if you can see these are little tiny octahedrons. And so the last deposition, and this chemically makes really good sense, was the copper oxide cuprite, which is normally bright red. And it was covered with millions of these little tiny cuprite octahedrons. And then you had the last minute, you had a little bit of malachite grow on these bright red cuprite crystals. And so they're all covered with these little cuprite octahedrons. We have a fairly large group of 3 stalactites that are partially coated with azurite. These are actually iron oxide. They're the iron oxide goethite. And they got a light dusting of malachite. but retains most of the azurite. The most exciting place was down in the breakdown piles of that collapse that formed, because you would get pools of water that retained water far longer than the other parts of the cave. And so the crystals basically had tons of time to grow. And so you're looking at azurite crystals in the realm of 3 inches forming down in these little ponds. And for Bisbee, that's a substantial azurite crystal, 3 inches. This specimen right here, the crystals, the larger crystals are about 1 inch. But again, this formed down in that pile with these bugs. You also got an extraordinarily bright malachite forming in some sections of this, as you can see in this one piece right here. Very highly chatoyant, a really beautiful malachite. Now, while we're on the subject of different minerals and caves, okay, in Bisbee, we have 31 species that have been recognized in the oxidation caves. Now, we are very particular on where we draw that line, because the ore bodies are often directly underneath the cave. So we are looking at in the physical opening, okay, that with these species were found. If we were to go and look at the ore body itself, then the number would be around 300 different species. Just to make note, there's 340 different mineral species that have been discovered in Bisbee to this point. But these 31 are found in caves, and many of them regularly. Some of the more unusual caves, and most of these have been completely mined out, so they no longer exist. There was a large lead cave on the 200 level of the Shattuck mine, and it was filled with cerussite, some andesite, and it was mined as lead ore, lead silver ore actually, because right next to it is a rather unusual species to be found in a cave. It's bromargyrite, the silver bromide. The silver is not particularly unusual, but the presence of bromine, there's not a lot of free bromine floating around in nature. And then we'll just drop below and we'll look at matramite. Now that caused a big stir when that cave was hit. It was only a 60-foot diameter cave, about 15 feet tall. And it was filled with the lead copper vanadium hydroxide. And everybody got wound up over that, because vanadium is a very valuable metal to be used in alloying with steel. So they were very excited and hoping that they would be able to continue mining it. But it was largely restricted to the one cave. And there were stalactites of matramite in the ceiling, but they rarely, 2 or 3 inches was about their extent. And then you had this more botryoidal forms on the walls and in the floors. Some of it is actually really bright and rather sparkling, and as is the one on the left. The one on the right is rather dull and uninteresting. But this cave was completely mined out, as the lead cave was. And this last one, the cuprite cave, which was very famous at the time it was hit, but almost nothing was recorded about it. I mean, it was like, ooh, we hit a cave filled with cuprite, and then that's about all they mentioned. Cuprite would have excited them because it's around 80% copper, so it was unbelievable ore. And it was hit on the 550 level of the Irish mag mine, just a few years before the Irish mag completely shut down. And they mined through it. There were reported stalactites of cuprite. Most likely what that actually was either an iron oxide, like a goethite or a hematite. A stalactite had formed, and then it was either coated with cuprite crystals. Cuprite itself is not going to like to form stalactites. It tends to like to make its little octahedrons, or in some cases dodecs. The other alternative would be is that you had native copper coming down in stalactite type forms. And one of these exists, although we cannot determine if it actually came from one of the caves. It's about 18 inches long, and it is intensely coated with cuprite. And a mass of native copper that's just coated, which would be more typical of what you would expect, just a coating and not a pure stalactite. Another interesting feature about Bisbee's caves is that these caves created a large number of monocrystalline stalactites, which means that the stalactite themselves are considered a single crystal. Most stalactites, if you go to Kartchner or Colossal or or Carlsbad, most of these are aggregates of thousands or millions of tiny little crystals. But in the case of Bisbee, a lot of these are just single crystals. They typically have a triangular cross section. So you can see here, there's a rough triangle forming. And then here you can see a little bit of crystal termination, which you can see better on these right here. You can see the crystal terminations on the ends of these stalactites. The most famous cave, definitely not the most attractive or scientifically the most important, was the Masonic Cave, as it has been known. And in 1897, there was a Grand Lodge meeting held in it. And this is one of the more common photographs of it. But understand, they only photographed a tiny piece of the cave. Okay, the cave itself was well over 200 feet across. Okay, in both directions. And this underneath these boards right here, the mine lagging, they had filled at least 20 or 30 feet minimum. Okay, because most of the cave was 64 feet tall. And they backfilled it so they could do this. And it was quite the elaborate show, because in the ceiling of the cave, they put in electric lights the Masonic symbol, which is the compass and the square. And they did it in electric lights. And the distance between the 2 points on the compass was 100 feet, and the distance from the end of the square to the corner was 120 feet. So it was massive. So you can see that this photo doesn't show nearly all of the cave. And some people reference that the other side of the cave is actually more attractive, but that's a matter of opinion. You can see another photograph of it. Now, this cave, like with many of the other caves, did not last much longer. By February 1898, just a couple months later, this area collapsed, most likely due to mining right nearby. The interesting thing was, and I guess in the other picture it showed better, that their shoes are quite muddy. And that tells you it took quite an effort to get down there without ruining their clothes, because they went to where the Queen Mine Tour parking lot is today. They went down the Czar shaft 200 feet. And then when they got down there, every 10 feet was a candle marking their path. And then at every intersection, there was a miner who was also a mason guiding them to make sure they didn't get lost. Because even at this early date, the mines in Bisbee had a couple hundred miles of tunnel. It's easy to get lost in that. The largest cave was found in 1913. And it's interesting because it was found on night shift. And the miner went back after a blast, and he went in there and he looked up and he could see what he thought were stars. So he reported to supervisor that they had blasted through to the surface, which would have been interesting because he was on the 300-foot level. So there would have been a lot of rock on top of him. But it turned out it was just the crystalline stalactites and probably water droplets that were reflecting his candlelight back. But definitely a good sized cave. Now, it vertically traveled up at an angle, maybe about 30 degrees, and it extended vertically originally 172 feet. And it was 340 feet across at the largest place, and typically never extended as a vertical opening more than 60 feet. Now, this one was accessible up into the 1980s, because some of you might remember that the Shattuck mine really did not shut down until 1983, because they were still doing some exploration there. And that cave was easily accessible at that time. And it had collapsed significantly since this time right here. So the actual opening today is much larger, and it's at least 700 feet long now, up at an angle, and actually goes right out to the surface. But it would not have at that time. And it's been exposed to some pretty heavy caving. And it was partially backfilled by the mining company, which is interesting because you can see stalagmites peeking through the backfill still. It never was quite as famous as the Grand Masonic Cave, but it did get some attention. The Elks had a dance in the cave in 1916. Part of it was shipped to, or pieces of it was shipped to the Michigan School of Mines. And it's pretty well photographed. We'll look at some of these photographs real quick. And you can see some of the photographs. So it was a well-decorated cave. From my experience of being in there in the 1980s, it did not have the copper tinting, at least from what I was able to see. About 1/3 of the cave roughly exists. And it was white and brown, very typical cave-like. I don't remember much in the way of the greenish colors that many of the caves are very well known for. And you can see another picture right here. Now, the caves themselves were sort of publicized. I mean, when they hit them, people could go see them. Unlike today, mining companies tended to like to show off what they were doing. And so if you came to Bisbee and you had relatives, or even if you didn't have relatives and you wanted to see the mine, you could make arrangements to go underground. And if there was a cave available, and up until the mid to late 1920s, there would have been caves regularly available to see, they would take you into a cave. There are countless documents showing that people visiting caves and visiting the mines, and you can see some pictures of some ladies in the cave, and one of them's holding a fragment of stalactite. And you can see some visitors in the Shattuck Cave in the black and white photograph in the bottom. And then going up into the late 1960s or early 1970s, you have a color photograph of two people underground in a cave.
Now, the last of the caves that was hit was in 1926. And this was a large cave. It's about 220 feet across, and the height was about 40 feet tall. Now, this is special is that it's the highest in elevation cave. It's located 5,780 feet above sea level. It was discovered by some leasers that were driving arrays off 7 Level Southwest. And they intercepted the bottom kind of off to the side. They noticed some oxidation down below. It ended up being just pure pyrite. So this cave remained unmined on it. And so it's still in existence today, but sealed off. There's some shots of it. These were all, as you can see, taken in the 1970s. At this time, the Queen Mine Tour was considering opening it for tourism, but that fell through. The locals will notice the Higgins Cave. When you do your research, though, you'll find that all the referencing will be in the Southwest mine, and that's where it actually is at. Now, one other cave that lasted for quite a while was this one here. The stalagmite in the center there, it was lightly green in color, and the stalagmite's 14 feet tall. What happened to this cave is Edmund Hovey from the American Museum of Natural History was in Bisbee, came to Bisbee to work on a mine model for their display in New York. And a few months before he got there, the mining company intercepted this cave, and they kind of sealed it off and made restricted access to it. But when Hovey came, he was allowed to go in there, and the mining company wanted to try and preserve it. So with the mining company's help, Hovey actually excavated several tons of this material and shipped 50 boxes back to New York. And they created a display, and here's photographs of the display in New York. Okay, this display would last until the 1970s when they did a remodel of it. And after the 70s, the stalagmite to the right was on display until just a few years ago when they did another remodel. Now you guys can see pieces of this cave. They're on display here at the Bisbee Historical Museum. They're part of the, they're on loan for their cave exhibit here. Now, the demise of the caves. Okay. What happened is, because since they were associated with the ore, there was a lot of mining around them. Okay. The most common thing that happened, it was they were totally backfilled. Okay, they took the waste from other parts of the mine to fill them in to keep them from further caving in and affecting other parts of the mine. The small ones that did not get filled, or ones that were too high in elevation, you can see collapsing in them. This one's the Cave in the Copper Queen mine that's my brother talked at the very beginning of the talk. And you start seeing the boulders falling. You see some massive cracks in the speleothems here. This one's actually kind of neat. The boulder on the ground is 60 feet across, and the tan that's on those boulders is the floor of a sag cave. That when the stope collapsed, it exposed it, and the rest of the cave is up in the ceiling. And here's another one that was exposed. You can see stalactites on the ceiling above, right in there, and you can just see the entire floor is just collapsed on it. So of the caves in Bisbee, very few exist today that haven't been impacted due to mining. Yeah, there's hundreds of them, anywhere from the size of a bathroom to hundreds of feet across. Now, we do see surface representations due to these collapsings, both the paleo, okay, and we're going to start looking at marginal cracks, okay. There's marginal cracks right there, and there's some going up, like right in here. Now, these marginal cracks were important, these surface features, on locating new ore deposits, and these were used all the way to the end of Bisbee to look for these oxide deposits. After the ore deposits were mined, though, further movement on the marginal cracks happened, and that's what's exposing it. We'll take a look at some of the marginal cracks. Here's one underground in 1899. Very classic photograph of a marginal crack. That this has been further movement's been on it due to mining, and here's one in the recent past. A marginal crack. Okay, and just to let you know, we have different books that we've published, Doug and I together, or myself on my own, which are available. And Annie has some of them available in the museum library. Or not library, gift store. We donated them so she could sell them. But before I would buy one, I would consider doing this. You go to our website and you go down here and you skip books. You don't want books, you want downloadable books. Every one of those books is downloadable for free. Okay, and for like the geology part that my brother discussed, and for a lot more detail, you can download it and read it on a Kindle. They're PDF files, and you can read them. And they're all available there. I'm an old person and I like hard copies, but we put them out there so you can just do your work, particularly like the geology, where it'd be nice to just sit there and read it and be able to look at the
the charts and diagrams in front of you. And are there any questions?
Oh, thank you so much, Richard and Doug. And yes, we do have questions. The first one is from Kenneth. He asked, did the shoebox azurite roses also come from the same place as the specimen shown from the Czar mine in 1895? He said, it appears as though the azurite specimen is trying to grow a few roses.
Yeah, they are little rosettes on that. The shoebox ones, they come out of the dividend fault zone in the Czar and Holbrook.
Yeah, the shoebox azurites, if you were to hold one, there's no real point of attachment. What they were growing inside a very soft clay along the dividend fault. And when they hit them, they hit tens of thousands of them. Okay. So many, in fact, it was one of the few times in Bisbee where good azurite specimens were shipped as ore. Normally miners would take them, but they had so many of them. So these roses grew inside of a soft clay, and it allowed for the perfection of the crystals just to be just a little bit more perfect. These formed under solution, direct contact with the copper bearing solutions.
Okay. And Jeff has asked, how prevalent is tellurium in the mines and caves? And did it have any value? I may have mispronounced that.
Trillium's rare. Okay. It's not recognized in any of the caves, but it is found in the ore bodies now. In fact, the mineral named after our dad is a copper tellurium oxide.
Yeah, graphite is a copper tellurium oxide.
Yeah.
It is present, and native tellurium is found in the sulfide ores. Elemental tellurium, which, by the way, is not a metal; it's a metalloid. Yeah, it's one of those odd ducks.
And Ken has asked, did the 1920s cave never open to the mine tour for preservation reasons?
It was cost that kept that cave from opening. Okay. They felt they were going to have to make it handicap accessible, and Bisbee's a lot different than it was back in that time in the 70s. The economy was pretty depressed, and spending the money required was going to be quite significant, and that's what kind of faltered.
But in a mining aspect, there are no difficult challenges, really, are there?
No,
Not in a mining
that's
aspect.
lots
It's
of
good. Yeah, lots of money, but it's good, solid ground. So the cave is definitely still in existence. It's not like some of the others which were in really bad ground and would not have survived. That one, I have little doubts, it's still relatively intact.
Yeah.
All right, another question from Jeff. Was there any float copper?
Not inside the inside the caves. There was gold that was floated out, and that was in the cave in the Uncle Sam. Okay. The copper that we get is mostly crystallized copper down below. Inside the ore body down below.
Okay. And Ken has asked, over thousands or millions of years, the backfilled caves would likely evolve into new unusual formations, possibly?
Okay, so yes, the caves are some of them are continuing to grow. The backfilled ones are going to kind of turn into breccias over time. Remember the environments that formed these caves originally have changed because of all the mining that has happened around them. So the fractures that used to bring water into the caves to develop the speleothems in the cave itself may or may not exist any longer. Okay, and water may get diverted through.
But the neat thing is, the old caves may not be doing much, but the actual mine workings themselves, on the other hand, that's where things get exciting.
Yeah.
Because those will become caves in many cases. It's just going to take a while because like in one area, there's an old bucket underwater, underground, and it's just completely encased in aragonite. And you'll find 6 or 7 inch stalactites of calcite and aragonite scattered uh, the ceilings of tunnels that have been undisturbed. So, well, in the one case, iron oxide stalactites go from floor to ceiling. So in the areas that are above the water table, which is a good chunk of the Czar and Southwest mines, it's the actual mine workings themselves are slowly becoming caves. Well, actually, some areas are going pretty quick.
Yeah, yeah.
All right. And April has asked, the large cave that still exists that was considered for tourism, what is
Yeah.
its name and why was it sealed off?
It's locals call it the Higgins Cave, but it's actually most people refer to it's better referred as the Southwest Cave because that's where it's actually found in the references from the period reference it as the Southwest Cave. And it was sealed off to keep people out. Vandalism, which is a problem with caves. Yeah.
All right. Thora has asked, what caused the marginal cracks and was there any influence from earthquakes?
Okay, so no influence on Earth from earthquakes on these. It's actually subsidence. So when the caves are collapsing, uh, the displacement of volume is causing the cracks. And just like the mine workings collapse, they'll also show surface subsidence.
Now the difference is the marginal cracks later healed with largely with calcite and aragonite. They were filled in. So if you came to Bisbee in, let's say, 1877, you would not have seen them unless you walked right up on top of one and you were studying the geology. But as mining went on, they started to expose themselves.
Yeah, yeah. Inside the mine tour, about 200 feet, there's one that you can look at underground. And it's got travertine calcite all over it.
Yeah. So they're geologically old.
Yeah. Something kind of interesting, the other day we were doing repair work in the mine, 1,700 feet back, and we actually exposed a small oxidation cave. It had oxidized over pyrite, so you could see it's like having a little miniature model. The thing's only like 20 feet across. And you can see the collapse structure, you can see the iron oxides, you can see the void that was created by the oxidation. Not a whole lot of decoration in it, just one little tiny spot of not very interesting stuff, but it was kind of cool.
Yeah. Oh, and I have to be careful when I say geologically. Okay, we're looking at less than 1,000,000 years old for most of these, if not less than 100,000 years old. So, in a geologic sense, they're very young. Okay, in a human sense, they're very old.
All right, thanks for that. And another earthquake related question.
Yeah.
Did the 1887 earthquake affect the Bisbee mines?
Not really. Yeah. At that time, Bisbee was a big mining camp, and there's no records of really anything than a few boulders rolling off the hill. Nothing underground. Keep in consideration it's how the energy waves from the earthquake are traveling through the rock. When hard material like the mine is in, the energy waves are going to pass through. It's when you get soft material like topsoil and stuff, the energy waves compress. That's why when you California, let's pick on California here. That's why in the earthquake areas they want to anchor you guys to bedrock on your houses. That's why the house becomes actually, or the building becomes part of the rock unit. It's a lot less affected.
All right. And were there any evidence of native peoples being or using any of the caves, being in or using any of the caves?
No, it's the reason for that is they're too deeply buried. The only access was through mining on these. So no openings to the surface. That we're talking just in the mining district.
And Joe has asked, where is the Southwest Mine located?
Well, part of it's the Queen Tunnel, which the mine tour's in. Okay. It has several different entrances, but the Queen Tunnel of the mine tour is the third level Southwest mine. It's the main haulage level for it. It continues up to the 6,000 foot elevation on the hillside. I don't know if you, sometimes you can look back up towards Old Bisbee, and way up high up on a hill, you can see a head frame, and it's looks like a metal building. It's a very unusual head frame, and that's the sunrise shaft of the Southwest mine. It went from the top of that shaft to 200 feet below where the mine tour parking lot is. And then there were several tunnel entrances. Most of them were located in Hendricks Gulch, which is near where the glory hole is. If you're familiar with Bisbee, the Copper Queen open cut, that canyon up there behind the post office. There's the fifth level, which is Southwest 1915 on it. And then there's the sixth level and the seventh level entrance up there as well.
All right. And do you foresee any further mining or extraction in the future?
That's hard to tell. It's an economic thing. And with mining, it's not about today's price. Okay. It's about the future price, because it takes so long to start a mine. It's gonna be 10, 15 years. If we said today we're gonna do it, it's gonna take that long. So when the people are making the decisions on doing this, because these are quite large capital expenditures, they're $1 billion plus, most of them. That's what they're looking at. It's not the economy of today, it's the economy of the future.
And Chris has asked, is there any chance access to a preserved cave can be included with the Queen Mine tour someday?
Not currently, I don't believe. Okay, I don't want to say no for never, but not currently. The access from our point, from where we're at on the tour, is pretty difficult. Okay, it'd be extremely prohibitive on doing it. Yeah, I've looked at it in my own mind and read numbers, and it's quite substantial.
All right. Chris also would like to know if there is a photo of cuprite on native copper stalactite available to see on your website.
No, the only pieces that I know of is owned by a collector in Tucson. And I examined it and fairly recently, and I had never seen one like it before. It's good size. It's, as I said, about 16 to 17 inches long and about 3 inches in diameter. And it has a core of native copper. Now, cuprite on native copper is very common from Bisbee, and on the website there probably would be, but I haven't had time to see if I can take a picture of it. It's actually really sort of an ugly piece. Scientifically, it's wonderful, which is often the case with such specimens. Yeah, it's really, really ugly, but it is a scientifically just absolutely wonderful piece. But again, there's no provenance on it, so we cannot be sure. It appears to be an Irish mag piece, but the Irish mag mined a lot of cuprite and a lot of native copper in other areas too. So.
All right. Here's a question from Sean, and I appreciate this one because we're asked about turquoise quite a bit here at the museum. So were the turquoise deposits ever found near the caves?
No. Okay, it's the chemistry, guys, on this. The turquoise is almost all that's coming out of the pit. Okay. Turquoise is a copper aluminum phosphate, and it's needing that aluminum and phosphate coming off the granite porphyry. There's a little bit that came out of the coal in the Dallas, just little thin veinlets, not very impressive, and some actually crystals of turquoise, which is actually a big deal when you can actually see them. Most turquoise does not crystallize out, but it's not been recognized yet in a cave.
And did any of the caves suffer from a buildup of toxic gases?
The only one that would be a problem would have been carbon dioxide. You can look, when you go in some of these caves, you can see that the atmospheres were super saturated with carbon dioxide. You'll look at the calcite speleothems, and they've actually been eaten away by carbonic acid, and it leaves kind of like a snowy, frosty coating on the outside of them. And this is due to the high carbon dioxide. And in some places, you'll actually find azurite in with the calcite. Again, the azurite requires for it to deposit supersaturated carbon dioxide environments.
So it hasn't, when the caves were forming, many of them would have had an environment that the carbon dioxide levels would have been way too high to support life.
Yeah.
I don't have any records of a carbon dioxide, let's say flooding a section of the mine, except with the siderite areas. Possibly because the limestones are so broken up, they were getting indirectly oxygen from the surface. But some of them, like that azurite cave that was found in 1895, had very little free oxygen when it was forming, because it was all being used up immediately in the formation of the azurite and cuprite and the iron oxide. So I mean, when it was forming, there was definitely not enough oxygen to support life.
And our friend from Ireland, Pamela, who is one of the whose ancestor is Thomas Higgins, has asked, where can I get further info about the Higgins Cave and the Southwest Mine that you mentioned in your talk?
Okay, for the cave, she can download the book. Okay, and then probably easiest for her to look at it, and it's got a detailed description of the discovery and more photographs of that.
And if you were to look in Seven Bells on just at the heading of the Southwest Mine and the Higgins Mine, it will have descriptions of the mines in reasonably good detail. We're working on those, and they take time to develop, because we're working on a mining history, and that's
in her case, which she'll find interesting is you have the Higgins mine, the Southwest mine might right up to the boundary line. In fact, there's a tunnel that's right on the Copper Queen Higgins boundary line, and that cave is so close.
yeah.
Yeah.
He wasn't very far away from it, was he?
No, he was.
Yeah.
Yeah. So it's kind of fascinating on that.
All right,
Yeah,
we'll just do a few more questions and then I'll let you two get on with your day, because I think we could go on and on for a couple hours here. I'll answer Aurelia's question. She was wondering if there are hard copies of the book available. We have some available at bisbeemuseum.org in our store section. We only have 3 copies right now, so run to the website to purchase yours. Everything is tax-free on our website because we are a nonprofit. Otherwise, you could go to Amazon and their books are available there. But support a nonprofit, please, and purchase directly from the museum. And let's see, are there much in the way of tunnels or caves below Old Bisbee or up the divide?
No. And this is why there's no real heavy mining underneath the town itself. Is okay, Main Street, Bisbee, that's the Dividend Fault. Okay. And so we have the museum. I assume most people know where the museum is and where the Copper Queen Hotel is. And we have where the mine tour is. Where the mine tour is at has been down dropped 3,000 vertical feet. Okay, so it got protected from erosion. Where the museum is on this hillside, it got hit with erosion. In fact, where we're sitting on, the rock units are 1.7 billion years old. It's the penile schist, it's our basement unit. Now where the mine tour is, when you go on the mine tour, that's between 350 and 400 million year old rock. It's the Escabrosa right there.
So it's very young.
So it's very young compared to where we're at. So erosion keeps the mining from coming over here. Because the copper that was here where the museum was at, and you know, the gulch and the Copper Hotel side, that all got eroded off.
Now they did punch a few prospect tunnels, but not much.
No.
Now, if you go down to Bakerville and Tin Town and those areas, those are heavily mined underneath, but they're so deep. Yeah, I think everything's at least 770 feet below the surface. Most of them between around the 1,300 foot level or deeper. So it's pretty deep. But yeah, Bakerville, Tin Town, South Bisbee, those areas were heavily, and of course Lowell was, but it no longer there, or most of it isn't there. So it was mined heavily underneath.
All right, so our last question, how much copper still exists today within the Warren Mining District?
Okay, so there's a lot of myth on this, and this goes not for just Bisbee, okay? You know, we gotta deal with real numbers. The last real numbers I saw, and it was just copper numbers, was 2 billion pounds. Average grade of the ore would be 0.4%. So it's okay. Nothing to write home to mom about, but it's okay. Again, you know, startup costs would kind of hold things back.
All right, well, Doug, Richard, thank you both so much for joining us today.
Thank you. Well, thank you.
And thank you to our audience. I hope to see you again on Saturday, September 20th, when we welcome John Langelier, who will examine the Buffalo Soldiers in Cochise County. Have a great day, everyone. Bye.